Hello, young scientists. Today, we are about to embark on a fascinating journey to unravel the mysteries of light and learn all about how it travels. Are you ready for an exciting adventure? Let's begin with the basics. So, what exactly is light? Well, light is a form of energy that travels in waves. We can see light because our eyes have special cells that detect light waves. Think of it as a super speedy beam that helps us see everything around us. Imagine your room getting brighter when you switch on a light bulb. That's light at work. How light travels? Light travels as waves, a bit like ripples in a tank of water. These waves can be seen as a series of up and down movements. However, waves can travel in straight lines. This is because the direction of the wave is perpendicular to the direction of the energy flow. For example, water waves can travel in a straight line toward the beach, even though the waves are moving up and down. This is because the direction of the wave is perpendicular to the direction of the energy flow, which is towards the beach. So, we can say that light can travel in both waves and straight lines. The distance between one wave peak and the next is called the wavelength. The color of light is determined by its wavelength. Shorter wavelengths produce colors like blue and violet, while longer wavelengths produce colors like red and orange. But unlike sound waves, light waves can travel through empty spaces. This is how we can see stars even though they are billions of miles away. Light waves also travel much faster than sound waves, 300 million kilometers a second in fact. One of the most important properties of light is that it travels in straight lines. This is why we can see our reflection in mirrors. Light can perform an amazing trick called reflection. Watch closely. When light meets a shiny surface, like a mirror, it bounces back. We call this phenomenon reflection. It's like a game of catch with light. There are a few exceptions to the rule that light travels in straight lines. One exception is diffraction. Diffraction is the bending of light waves around an object. This is why we can see the edges of objects even when they are not directly in our line of sight. Another exception to the rule that light travels in straight lines is refraction. Refraction is the bending of light waves when they travel from one medium to another. This is why we can see a pencil in a glass of water look like it is bent. When this happens, it becomes focused and can make things look bigger. Isn't that simply astonishing? However, for most practical purposes, light can be considered to travel in straight lines. This is why we can use mirrors to create reflections and lenses to focus light. Now, prepare to be dazzled. When light passes through a special crystal called a prism, it splits into all the colors of the rainbow, forming a magnificent spectrum. It's like witnessing pure magic unfold before your eyes. Let's step outside for a moment. Have you ever marveled at a beautiful sunset? Well, sunlight appears white, but it's actually made up of all the colors we just explored. When it travels through the sky, it scatters, creating those breathtaking sunsets that leave us in awe. Here's a real eye-opener. If we focus sunlight using a magnifying glass, it can become super hot and even set things on fire. Remember, though, always prioritize safety. Now, let's take a trip to outer space. Did you know that stars are similar to our sun, but they're incredibly far away? Their light travels through the vastness of space to reach us, filling the night sky with those twinkling, magical stars. So, there you have it, our young scientists. Light is truly remarkable. It travels in straight lines, bounces off surfaces, splits into colors, and fills our world with wonder. From the blazing sun to the glimmering stars, light is everywhere. But before we say goodbye, please remember to like, share, and subscribe to our channel, Reading Readiness Centers. Keep that curiosity alive, keep exploring, and we'll be back soon with more exciting discoveries. Until then, stay curious, keep shining bright, and let's continue this amazing journey together. Goodbye for now, young explorers.